In the last video, we kind of strayed away from creating a polygon mesh, and instead we tried to do something new, which was to create a geometric modifier instead. So in this video, I wanted to continue the spirit and try to do something new again by creating a controller that is driven by a lab graph. So the controller we're going to create is going to be a position controller, and for this I'm going to create a sphere. And just to make things simpler, we're just going to drive one of the coordinates of the sphere. Let's say it's going to be the y coordinate. So if I select the sphere and if I go to the motion panel, I can see that currently there is a default position controller assigned, which is just a Bezier position controller. But if I expand it, I can also see that I can assign custom values or custom controllers to each one of the three components of this position controller. If I select the Y position, I can press the assign button, and if we have our lab installed, we should see a new controller called float function, which is right here. Float function is basically a lab template which allows you to create graphs that drive a float controller. So if I double click on it and assign it, we can see that it has assigned a new Y position controller, and for the inputs it is taking two values, taking input and my input, which are the default settings for a templated lab float controller. If I select the position and Y here, which is already selected, we can see that this is very familiar to what we saw before with other types of lab plugins. We have our edit plugin button to start editing the graph, and we also have the two inputs. In this case, we have two inputs as opposed to one that don't really do anything. So to make things very simple at first, let's start editing the plugin. And let's just allow the user to specify the Y value of this controller directly through a spinner. So let's take our input value and let's just connect it directly to the output result. And if I do that, now I can select some kind of value for our input, and we are able to drive the sphere's Y coordinate very easily. And we can assign a controller to this input as well, so we can kind of have a tree of controllers that drive the graph that in turn drive the other controllers. So this is very simple, but let's try to do something a little bit more complicated. Let's try to add a multiply node that takes the user specified input as one value and then takes some kind of other multiplier as another value. We'll just use the my input value for the other value, and as a result we'll produce the output of this multiply node. So now if I drag this, it doesn't do anything, but I can use my input to kind of multiply the effect of the first input, so I can move it faster or slower. And just to make things even more interesting, as opposed to letting the user control the Y coordinate, let's have time drive it. So time, 3ds Max has the time slider here, and as I move the slider, this changes the scene's time. And let's actually try to get the lab to use the time of the scene to specify the Y coordinate of the sphere. So let me rename this port, my input port, which is currently a floating system single, which means it's a floating point value, and it's important it has to be a floating point value. And all I need to do for it to take the scene's time is rename it to time. As soon as I rename this port to time, it tells the lab that you want to use current scene time for the input of this port. So now as I drag this value, I can see my sphere move in the viewport. And because we are multiplying this by input, if I scale up the input value, it's going to increase or decrease the effect of how our time drives our sphere. As a last kind of a note, let's also make it more interesting by making the sphere kind of go back and forth in the viewport. And to do that, let's add a sine node. A sine node is a basic mathematical operation, which allows trigonometric operation, which allows you to kind of have objects move in a circular or kind of a sinusoid motion. And inside the lab, we use the default .NET sine function, which is system.math, and as you can see, if you type system.math, you automatically get a whole bunch of different math functions, and these functions are built in .NET functions. And for the sine functions, we have systemmath.syn. If we create this, now we can wire time into it, and we can multiply the result by our input. Now if we drag the controller, we can see that the sphere just kind of goes back in place, and it is using the sine wave motion to do this movement. So I think this pretty much covers the linear float controllers. Again, you can have crazy graphs in here. This is just a very simple example, but it gives you an idea, and we will cover more complex graphs in the future.